Autophagy is tightly controlled by nutrient-sensing pathways that act as molecular switches, helping cells adapt to energy availability and metabolic stress. Among these regulators, mTOR, mechanistic target of rapamycin, and AMPK, AMP-activated protein kinase, are especially influential. Together, they determine whether a cell will conserve energy and build new components or enter a recycling mode to clean up and reallocate resources. Under conditions of nutrient abundance, such as during overfeeding or chronic high-fat intake, these pathways are disrupted and autophagy is suppressed. This has significant consequences in the context of obesity, where dysregulated autophagy contributes to fat accumulation, insulin resistance, inflammation, and mitochondrial dysfunction. Yet these same pathways also present promising targets for restoring autophagic balance and improving metabolic health. The mTOR pathway is activated when cells sense high levels of nutrients, especially amino acids and insulin. Once active, mTOR acts like a metabolic accelerator, promoting cell growth, protein synthesis, and lipid storage, all processes that are important under normal conditions but become problematic when persistently turned on. Chronic mTOR activation directly inhibits autophagy by suppressing the initiation of the autophagosome formation process. In obese individuals, elevated insulin levels and nutrient overload keep mTOR constantly stimulated, preventing cells from entering a cleanup mode even when they are under oxidative or metabolic stress. As a result, damaged mitochondria, misfolded proteins, and excess lipids accumulate, particularly in metabolic tissues such as liver, muscle, and adipose tissue. This buildup contributes to cellular dysfunction and aggravates obesity-related conditions like type 2 diabetes and fatty liver disease. In contrast, AMPK functions as a metabolic brake that is activated under low-energy states, such as during fasting, calorie restriction, or exercise. When ADP levels drop and AMP levels rise, AMPK turns on pathways that conserve energy and restore balance, including the activation of autophagy. AMPK promotes autophagy both by directly stimulating the core autophagy machinery and by inhibiting mTOR activity. This dual action allows cells to shift from nutrient storage to nutrient recycling and stress adaptation. In the context of obesity, however, AMPK activity is often blunted, particularly in liver and muscle tissue. This reduced activation means that autophagy fails to ramp up in response to metabolic stress, leaving damaged cellular components in place and impairing the body's ability to regulate fat and glucose metabolism. Fortunately, both mTOR and AMPK are modifiable through lifestyle and pharmacological interventions. Fasting, even for short durations, reduces mTOR signaling and increases AMPK activity, stimulating autophagy and promoting the breakdown of stored fat. Similarly, physical activity is one of the most effective ways to activate AMPK in muscle and liver, enhancing autophagic turnover and improving insulin sensitivity. Diets low in refined carbohydrates and excessive protein can also help reduce chronic mTOR stimulation, especially when combined with exercise or time-restricted eating. Nutrients such as polyphenol, omega-3 fatty acids, and plant-based compounds like resveratrol have also been shown to activate AMPK and support autophagy without excessive stress. Certain medications, including metformin and rapamycin, work directly on these pathways and are being explored for their potential to restore autophagic balance in metabolic disease. Metformin activates AMPK and has shown promise in improving liver function, reducing visceral fat, and lowering systemic inflammation, benefits that likely extend beyond its role in glucose control. Rapamycin, an mTOR inhibitor, has a more complex profile, offering metabolic and anti-aging benefits in some contexts, but carrying the risk of immune suppression and impaired wound healing in others. The challenge moving forward is to fine-tune these tools so they restore natural autophagic rhythms without pushing the system too far in either direction. In essence, the balance between mTOR and AMPK is a central dial controlling the cell's response to nutrient cues and stress. When this dial is stuck on growth mode due to chronic overnutrition, autophagy becomes suppressed, and the body loses its ability to clear damage and adapt to metabolic fluctuations. But by resetting these pathways through fasting, exercise, smart nutrition, and potentially targeted therapies, it becomes possible to restore the flexibility and resilience that autophagy provides. This not only supports healthy weight regulation, but may also prevent the progression of obesity-related diseases and promote long-term vitality.